Hi, my name is Lauren Davis. For this presentation, I will be discussing deforestation in the Amazon rainforest and how systems thinking can help find potential solutions. So, the Amazon, the largest rainforest in the world, is burning. As the world seeks to find solutions to address the increasing problems of climate change, trees inevitably hold a major part of that answer. Yet deforestation, the mass destruction of trees, continues, sacrificing the long-term benefits for short-term gains. About 17% of the Amazon rainforest has been lost to deforestation as of 2019. Before I explain the model itself, it's important to understand how it was built. I'll briefly explain each element and how it is represented. So the first component of the model is stock. Stocks are the measurable elements of a system. They are an accumulation of stuff that can increase or decrease over time. For this model, stocks are the trees or total amount of forest area, forest products, population, the open or cleared land, biodiversity loss, atmospheric carbon dioxide, agriculture, and economic growth. They are represented with a box. Next, stocks are changed by directional inflows and outflows. These flows describe the actions or processes that affect the accumulation of stock. Inflow adds to, outflow takes away. Here, our inflows are tree planting, resource production, demand for forest products, births, land availability, and production of goods. Then, the outflows are natural tree death, deforestation, which here again refers to the cutting, clearing, and removal of trees, human mortality, habitat destruction, and stored carbon dioxide release. Flows are represented by arrows, and the control is marked with a circle. The third component is a converter. In a systems model, a converter holds information about the system that affects the rate of flows. The converters in this model are tree growth, tree mortality rate, production rates, environmental policy, and the legal and illegal harvesting rates. Converters are also represented by circles. The final components are the interconnections and coupling. Interconnections are used when one component of the system needs information from another, and coupling is what that interconnection is called. So examples are 1. Tree planting and forest size. As more trees are planted, the larger the forest will grow. 2. Population and demand for forest products. More people means more resources are needed to support the population. 3. Forest products and deforestation. The need for more forest products can be connected to increased rates of deforestation. 4. Poverty and agriculture. Another leading cause of deforestation in the Amazon is agriculture in poor communities. Many people's livelihoods rely on the goods they can produce. And lastly, number 5, economic growth and demand for forest products. As a country's economy grows, so does the demand for more resources, which will all be explained a bit more when looking at the model. But before I move on to the model itself, I will explain the purpose. The purpose of this system is to look at how deforestation impacts not only the environment, but also economics and culture. The model also helps us understand what can be changed to help solve or at least alleviate part of the problem. So with all the components put together, here is the final completed model. Beginning at the top, the model starts with tree planting. As shown in the previous section, tree planting is the inflow to the total forest area in the Amazon, and it is controlled by the growth rate. From the total forest area, we have 3 outflows. First, like before, is natural tree death. Second is the deforestation itself. In the Amazon, The cutting or burning of the rainforest is caused by a number of factors, so the rates of legal and illegal harvesting as well as environmental policy are converters. Then finally, the last flow consists of resources produced by the forest, and depending on the rate of production, we get forest products. Now at the bottom of the model, we can see the stock inflows for population. The size of the population determines the demand for forest products, thus connecting the need for products with the rate of deforestation, as indicated with the green arrow. Back at the deforestation flow, it continues into the cleared land, or the amount of cleared land. From here, we can see why deforestation is a major problem. The Amazonian rainforest serves as an important role in reducing greenhouse gas emissions, maintaining biodiversity, and providing for local populations. Rainforests store immense amounts of carbon and help sequester large amounts of it from the atmosphere. So when the trees are removed, the carbon is released back into the atmosphere, resulting in greater problems for the environment. In the model, the release of carbon is the flow caused by the cleared land, ending with increased amounts of carbon in the air. Next, clearing forest area also causes significant habitat destruction, resulting in increasing amounts of biodiversity loss. However, the purpose of clearing rainforests is not to create environmental problems. Deforestation is largely driven by cattle ranching, crop production, and other large-scale plantations, all of which require open land. Here, the green arrow indicates the connection between agriculture and poverty. Available land means more agriculture, which means more goods can be produced, resulting in economic growth. Brazil specifically has experienced significant economic growth because of agriculture and forestry. And lastly, when the economy producing the goods is growing, demand increases, bringing attention back to the growing problem of deforestation. So next, I'll discuss my analysis and conclusion, beginning with action points and potential solutions. So although environmental policies and forestry regulations are important, the model shows the problem is too complex to be solely solved this way. Implementing tougher laws is a good way to help slow the rate of deforestation and the harm to the environment, but it doesn't fully address the social or economic ramifications either. I believe the challenge is finding a compromise between making money but also protecting forests, wildlife habitat, and indigenous peoples' way of life. In other words, standing forest needs to be made more valuable than logging, clearing for crops, pasture, or land speculation. Other possible solutions, in addition to government policy, might be increasing reforestation efforts, educating others, using less paper products, and consuming less meat. So that brings us to the end. Here are my references, and thanks for watching.